So another topic, which would be better left to biologists and biochemists who actually know what they're talking about, is this discussion of polysaccharides. Now, I don't really focus on this too much, and the big reason I don't focus on this much is that it's not something that we can really practically do in the lab with the chemicals. Basically, these, to the best of my knowledge, these are mostly catalyzed through biological reactions. But big picture though, what are di and trisaccharides? Well, what happens is that we have all these alcohol groups, and as hopefully you remember from alcohols, we can form ethers. So what will happen is that these monosaccharides, these single units, will react with each other through a condensation reaction to give us a bridging ether and water. Now again, this is probably something that's mostly done through biological processes, because anything we would do would be a brute force approach to the lab. So there's something like a Williamson ether synthesis or something like that. You might be able to do it, but there's a lot of alcohols here and your control over it's pretty slim. So let nature do what nature does best. Now, as you can imagine, there are R and S chiralities associated with it, so depending on how you form the ether will dictate which of the disaccharides and trisaccharides you get. But big picture here is that all this is basically bridging back to your alcohol chemistry. We do form disaccharides by doing an ether synthesis. Now again, this is catalyzed traditionally through nature. We're not going to do it ourselves in the lab. But depending on which RS configurations you get, will tell you which of the disaccharides you get, and if we add on another unit, which of the trisaccharides, and as you keep sticking on there, which of the polysaccharides you end up making by this ether condensation.